Welcome back. The first problem to solve here is the visibility of the internal faces. Let me show you what I mean by that. If we apply a transparent material to the glass, this is what we get right now. We see the cracks. Usually we solve the problem applying a RBD disconnected faces with mode delete connected, and this doesn't work. Why is that? Well, if we take a look at the geometry spreadsheet, we see the opposite face ID and prim dist. This is because we used inside our HTA, we use the RBD connected faces, and we also store the primitive ID. But as you can see, the primitive ID is no longer matching the prim num here. So inside the simulation, inside the simulation, the primitives order has changed. So the opposite face ID attribute is referring to a polygon which is not the same polygon anymore. So we need to restore the original primitive order. Sort primitive by attribute, primitive ID, and now it works correctly. Okay, let me try to explain what I'm going to do now, and this is what we want to achieve. Okay, so we have the box, and we have a cutting line like this. We can define for each point of the line a vector attribute out, like this, basically a normal vector. Okay, and when we cut the surface, we end up with something like this. Okay, we transfer the attribute, the out attribute. So now we have over the surface the same vector, and so on. Okay. Now we want to move these points here in this direction and in this direction. So let me change the color. Okay, we can define the normal over the surface like this. And now it's easy because if the normal goes in the same direction of the out, we move in the opposite direction. Otherwise, we move in the out direction. This is the concept. Okay, let me work for on a different file for now, because it's easier to understand. We can create everything we need here, and then we can transfer the knowledge in our scene. So we have a box, a curve, which is our cutting line. I just put down a sample with the curve view attribute, polyextrude, and Boolean fracture, like in our HTA. So the first thing to do here is to create the out attribute, orientation along curve. We just need the out, and we can fix the target up vector to the z-axis. So we have something like this. Okay, now the out vector is planar or on the XY plane. Okay, now we can transfer the attribute, copy cutting surface attributes, out. Okay, now we have have the out attribute also on the surface. Now we need the normal. Over points, and we can create a wrangle. Now let me show you exploded view. Normal. Okay. As you can see, we have normal in the same direction of the out attribute and normal in opposite direction. Okay, so we also need to transfer the curve view attribute because we need it inside the wrangle, and we can say float t, it's our time, for now it's time, and float curve view is equal f at curve view. And now we can define a parameter called, I don't know, anim is equal to fit curve view between t minus 0.1 and t that goes from 1 to 0, and f anim is equal to anim. Let me see. Anim. We should have something, yes, like this. And I'm applying the attribute wrangle only on the inside group. Okay, as you can see, the transfer is not clean enough. Okay, so instead of transferring the attribute from here, I prefer to do something different, which is attribute transfer. Curve view and out. And now we have a much cleaner result. Okay. Now we can say that int sign is equal 1. And if the dot product, well, let me define the variable, vector n is equal v at n and vector out is equal to v at out. If the dot product between n and out is greater than 0, it means that they are in the same direction, so the sign is -1. And now we just need to set the position plus equal the out vector times the sign times the animation times some parameter, the amount, basically float amount is equal chf amount, the displacement amount. Okay. And we probably need a new normal. And now we have it. I found that by face area works pretty well. Okay, now we have an animated crack, but it's not enough, because if we leave it like this, I will say that it's boring and not realistic. Keep in mind that right now we are dealing with just one line, but in our final scene we have different radial lines. And I would like to see something like a different crack speed on each line, maybe a different length, meaning that a crack can expand from the origin up to the border in one case, and on another line the crack expand only till here, maybe. So speed, length, and the other one I would like to see a more, how can I say that, steppy behavior. Steppy, I don't even know if it's an English word, but instead of going linear, I would like to see something like this, so steppy. Okay, so we can define a new triangle, and the attribute transfer goes here. Let's call it crack attributes, and this runs over primitives. Yes, every line basically. Float seed is equal to chf seed int prim count is equal to n primitives, and now for int I equals 0, I less than prim count, I plus plus, we can define a speed fit 01 of random seed plus I plus something else that goes from the speed, from half the speed to twice the speed, and the same for length and step. Length goes, let me define a new number. Length, let's say 0.25 to 1.2, and step 0.1, 0.35. Okay, now we can grab all the primitive points, prim points, 0 I, and for each int pt in pts set point attribute 0 crack speed pt speed. Length and step. Okay, should be enough. Now we can transfer the attribute, crack everything, and now we add okay. Now let me define the variables. Float crack speed is equal to f at crack speed. Length and step. Okay. Let's start with the step. Maybe it's the hardest one. Okay. Steps is equal to int set. Basically, we need to know how many steps we need to cover the one. Seal 1 divided by crack step. And now for int I equals 0, I less than steps, I plus plus. If our time parameter t is less than crack step times e, then t is equal to crack step times e minus 1 and break. Basically, I'm saying that this is t. Okay. I'm saying stay here until you reach the first level. When you reach the first level, stay here until you reach the second level, and so on. Let me check. Yes, it seems to work. Okay. Now the second one, well, the speed is easy. It's easy. Speed. It should be something like t is equal to t times crack speed. It's just a multiplier. Okay, now we have, which speed we have? Well, 1.00, okay, it's the same. And for the length, we can say that, well, we can clamp the time. T is equal to clamp t between 0.0 and crack length. Let me see which length we have. 0.94, so it will not be so evident, but just a little bit. Okay, so we can change, if we change the seed here, we have a different length. .36. Let me see, a speed 0.5 now. Okay, it's working. Okay. The last step is to shift the time, because right now we are using the global time as our t, and so it always starts from frame 1, but we should be able to say this effect starts at frame 46. Okay, so we can define a parameter int start frame is equal to chi start frame, and now our t is equal to time minus float start frame divided by FPS, and if t is less than 0, just return. Oh, it doesn't change anything here. By the way, I made a mistake here, because this one is 1. Okay, now if we set the start frame at 50, nothing happens till, okay. Now let me change the parameters here. Cracks attrib. Okay. If we start from 1, okay. If we start from 50, okay. That's it. Now we just need to transfer all this stuff in our scene. Okay, back to our scene. We have to modify the HDA. Okay, let me make some space here. We need the orient along curve, out, and target up vector Z axis, out attrib. Then the primitive wrangle, and this is the crack attributes. Let me just copy and paste what we did before. This is crack seed. Okay, and I really don't like these magic numbers here, so let me set a few parameters. Speed min, speed max. I know it's boring, but it's more clean. Float length min is equal to CHF length min. By the way, we can say crack max. and step min and step max. Okay, speed min, speed max, length min, length max, step min and step max. Let me set few default parameters. Speed min 0.5, 2, crack length 0.25, 1.2, 0.1, 0.35. Okay. And now we have just one output, and we can set up another output. Okay. And now type properties, two outputs, parameters. Let's create a new folder called cracks. Where we can put the seed, and then we can create subfolders for the speed. Simple. We have speed min and speed max. We have length, length min and length max, and finally step. Okay, this is something. Okay. And now we have the second output. Okay, so after the sort, we can put down a normal, point normal, and we can create our wrangle for the animation. This is another copy and paste. Start frame, amount. Okay, this is crack animation. Maybe we can change the color. And even the shape. Okay. Disconnected faces and the final normal. By face area, we still need to transfer the attribute. So after the unpack, attribute transfer, we need to transfer from here, curve view out, and crack everything. Okay. Okay. Okay, because the simulation starts at 18. Okay. And since the simulation starts at 18, we can copy this parameter, copy, and set the start frame. Let me see. Okay, probably this is too much. Okay. Even less. And that's it. The next step will be to create the pop dust simulation. So see you in the next video.